Hi, virus students, it's Ms. Young. Today, what we're going to be talking about is that how can you measure biodiversity? So what we're going to do is we're going to look at what ecologists use. Ecologists are scientists that study ecology, and that is going to be all the interactions of ecosystems and all the species within them and how they interact with each other and also the ecosystem. And we're going to use these things called biodiversity indices. And there's a lot of them, and they can be used to determine if a community or ecosystem is diverse. They can also be used to compare two different communities or ecosystems to see which one is more biologically diverse. And they can also use it to make decisions about when they're trying to protect natural resources. We're just going to use two today. We're going to use one called species richness and another one called relative abundance. So first, we're going to talk about species richness. Now, species richness is going to be the number of different types of species in a community. And so you're going to be figuring out how many of this type of bird, this type of tree, this type of coyote, this type of ant, all those sorts of things. Now, as species richness increases, biodiversity increases. So when we have higher species richness, so the more types of organisms, we're going to have higher biodiversity. So let's take a look at this scene here. So in the picture, we got a couple of different organisms. And I want you to try to count how many different types of species are there to figure out our species richness. So when I was looking at this, and I am not a marine biologist, I was looking at it and I said, okay, we have 3 different species. I thought, okay, the fish, the coral, and there probably are different types of corals. So if you know more about this, you might have counted more, and also the sea turtle. So I said, in this case, species richness of 3. Of course, marine biologists would probably know a bit more, but for our purposes, we're going to just say it has a species richness of 3. Now what we're going to do is talk about the other index that we're going to be using called relative abundance. Now, relative abundance is a percentage of individuals of each species type. And so we're going to do a little bit of math here. When the relative abundances are equal, biodiversity is going to be higher. And I think you'll understand it a little bit more after we look at our examples. So let's go back to this. So we said we had 3 different species. So our first step is to figure out and count up how many individuals in each of those species, in the fish species, the turtle, and the coral, and then figure out how many total individuals we have. And so when we look at it, I said, okay, I counted 8 fish. I might have missed some. I counted 8 fish, 1 turtle, and 3 corals. That means we have a total of 12 individuals. So we're going to do a little math. To find out the relative abundance of the fish, what I did was I counted up the number of fish and divided by the number of individuals, 12, and I got about 67% fish. And yes, I did round. Now, if I do the same thing for the turtle, there's 1 turtle out of 12 total individuals, 8% turtle. And then if I looked at the coral, I said there was 3 coral species out of 12, that's 25% coral. So when I'm looking at this and I'm trying to figure out, is it biodiverse or not? When we have 67% of the species being 1 fish, that's not very diverse. So if we had closer of 33% fish, 33% turtles, 33% coral, then we would have said that was more biodiverse. Now, you can't just use one indice. You have to use many, and there's a little bit of subjectivity, and there's definitely providing some evidence. So all these numbers would be evidence, and your reasoning explaining what those numbers mean when you're trying to say which one is more diverse than the other. So then if we take a look at these 2 different tree communities, we have community 1 and community 2. There are a few different types of trees. We're calling them tree A, tree B, tree C, and tree D. And they're the same both in community 1 and community 2. They both have A, B, C, and D. So what we want to do is we have to figure out, we can't just say one is more diverse than the other. We have to have some evidence, and this is where we're going to use our species richness and relative abundance. So we're first going to look at community 1. I counted up and we have 4 different types of species. And so we have, species A, B, C, and D. So my species richness is 4. Then what I did was I counted up how many of species A there were. And I also counted up how many total trees. There are 20 total trees, and 5 of them are going to be of species A. So we have here we got 1, 2, 3, 4, and 5, and that's 25%. Then what I did, did the same exact thing for species B. So species B, there's 5 of them, and out of the total numbers of trees there, total number of individuals, which is 20, and I got 25%. Do the same thing for C. There's 5 of the C trees out of 20, 25%. And then I looked at species D, and again, I counted up 5 of them out of the 20, and so it's 25%. So when I'm looking at that and what I can make a conclusion, the relative abundance is very even, meaning that it's when we look at it, we have a good mix of 1 out of every 4 trees is going to be A, 1 out of every 4 trees is going to be B, and so on. Now let's take a look at community 2. Community 2, we also have species A, B, C, and D. So we still have the same species richness of 4. Now what we're going to do is we're going to do the same thing. And we're going to take a look at how many trees. So we still have the 20 trees, and we're going to count up the number of type A trees. There's 16 of them in this picture. 16 out of 20, because there's 20 total trees in this community, is 80%. Now, if I take a look at my B tree, there's only 1 of them. It's right here in the middle. Divided by 20%, 20, I get 5% of the trees are species B. Same thing for C. There's only 1 of them. It's right here. It's the one that looks like a Christmas tree, kind of. D really looks more like a Christmas tree, but we only have 1 of them. 1 out of 20 is 5%. And then when we look at species D, there's 2 of them. So 2 out of 20 is 10%. So now when I'm looking at it, and I want you to kind of think about this, if you close your eyes and imagine you're walking through a forest and 80% of the trees are species A. That's not very diverse. That means that most of the trees are mostly species A. So if we're looking at the difference between community 1 on the left and community 2 on the right, we can make the claim that community 1 is more diverse. And we can use our evidence being the species richness and the relative abundance. And then when we're writing out our reasoning, we need to include explaining how does that very even relative abundance show us that community 1 is more diverse. Alternatively, you could talk about how community 2 is less diverse. And in your evidence, you would have your relative abundance. And your reasoning, you could talk about how 80% makes up 1 type of tree. And you could do the same thing. So you could, when you're arguing for one or the other, you could also argue it's not community 2 because of this. So what you're going to be doing today is you are going to try to get out of an escape room. And the way you're going to do it is you are going to be doing some math and figuring out species richness and relative abundance and answering some questions about several different forest communities. And so it's up to you to get out of each of these escape rooms. If you have questions, we're always here to help you. I'm always here to help you, okay? So if you're ready for the challenge, go ahead and click next, and I'll see you in the first escape room.